Thank you for coming to my presentation. I was afraid that because this is Black Hat Euro's return presentation, so the audience is not coming to here. So it's very happy to see you. Thank you. But additional presentation slide is added to today. So I explained mainly the additional presentation material. So I will get started. Today I introduce you PASTA, Portable Automotive Security Testbed with Adaptability. You may already see, read a paper of this one. So main update of this PASTA is we developed this logo. It's very cool. So who are we? So today it's me, Tsuyoshi Toyama, only. Left side, it's me. So our company, Toyota Info Technology Center, the parent company is Toyota, so research center, and actually next week my company will be disappear. Very big news, and we will be Toyota, TMC, Toyota Motor Company itself, and absorbed to Toyota Motor Companies and one of the division of research center. So soon I will be a Toyota guy. Anyway, so some news is mainly dark reading said that Toyota guys developed the PASTA. It's wrong. Toyota Information Technology Center is a different company. So Toyota Info Technology Center guys developed the PASTA. It's correct. But soon, Toyota guys developed the PASTA is correct. So the first, I start a background. So background, as you know, lot of ECUs, electric control units, are in vehicle to realize comfortable driving, steering support, braking support, stabilizing, and making driving comfortable. And the ECUs interact with other ECUs via CAN protocol and share the sensor information, actuate, and move the actuators. However, the CAN protocol is very old and was developed with no concern about cybersecurity attack. And the result is that two hackers cracked Jeep Chrysler. It's a very famous incident, as you know. They remotely controlled the Jeep's wipers, audio systems, steering wheels, of running cars. As a result, Chrysler recalled 1.1 million vehicles. It was very big news, so it's called in vehicle industries. It's called Chrysler shock. But this stems from the problems of automotive industry itself. There is a delay in development of cybersecurity technology in automotive industry. Also, the lack of cybersecurity engineers in automotive industry. We have to solve the problems. That's why we developed a PASTA. Very big motivation. Here is a typical architecture of vehicles. Now, first, 2010, Washington University researchers attacked via OBD2 port, diagnostic port, and directly send CAN messages to ECUs and controlled. But now it's mainly between OBD2 port and ECU. There is a central gateway, some called gateway, and it works as a firewall. So it stops the malicious messages, I guess. And also IVI is a navigation unit. There are a lot of communication channels, USB, Bluetooth, Wi-Fi, etc., and connect to networks. So it is very comfortable, and it's connected to your smartphones. It's a very you can listen to your music in smartphones and talk, call in vehicles with hands-free. So it's very useful and comfortable. But sometimes it becomes a very big attack surfaces. Of course, there is the OBD2 port, and it becomes attack surfaces. And also, IVI is becomes attack surfaces. USB, also, of course, Bluetooth and Wi-Fi, cellular networks, the Charlie mirrors and Chris Barosek intruded via cellular networks. It's very typical attack surfaces. And in this background, a lot of hackers play in car hacking village like DEF CON. I heard that a lot of car hacking village is held in a lot of countries, but mainly I visit in the DEF CON, so this picture is a big shot in DEF CON. And also a hacking event such as CTF is very, very fun. I guess you joined and try to get a win. But however, in my opinion, it's just cracking something, not hacking. It's not creative. It is doubtful that it can be a systematic way of running vehicle security. It's just cracking the product who made by someone. It's not hacking. hacking must be creative. It's my opinion. Sorry. So there is no harmless real car for testers, and no generalized one. Of course, yes. Generalized vehicle doesn't exist. Generalized producers does not exist. So we need to develop a platform not only for crack, but also hack. Anyone can hack and study by playground vehicle. It sounds very cool. And your portable security technology can be evaluate its feasibility in common platform, and open and safe and attractive. Attractive is very important for hackers. For vehicle cybersecurity is required. So now the guys, here comes the guys again. They gave us a hint. They developed and presented 2014 and SideScan. Do you know SideScan? Yes or no? Anyway, they presented in SideScan. Actually, it's held in here, Singapore. They modified go-kart, and they say that it can be testing platform. But I saw that it's very, sometimes it's very dangerous and it's very difficult to replicate. So we developed a pasta, this one. It's attache case sized and portable and safe, and also including in-vehicle networks. So the philosophy of Vasta, a simple and very cool slide, I guess. Do you think so? So open and safe, adaptable and portable. Out of characters. Open, it must be open. It must be based on non-proprietary technologies. A lot of vehicle technologies are secret. So we developed full scratch, which can be opened. And adaptable, users should be able to rewrite the firmware of ECUs. Of course, you can't rewrite the ECUs firmware of commercial vehicles. And the redesign, you can redesign the architecture to connect to their own devices, for example. This is a big difference from hacking or cracking part of the devices or ECUs in commercial vehicles. And it's safe because it's, the actuator is simulated. It can avoid the incident of student. And portable, it's apparently portable. And it makes, it can be, so that users can study, research, hack it anywhere. But sorry, I couldn't bring to here today because of the some reasons, including my company will disappear. I'm very sorry. If you are interested in our pasta, please visit our office in Tokyo. So pasta is seems to be an ordinary attach case, but once it opened, pasta appears. Very nice. So it's of course it's portable. 8 kilogram, a little bit weight, heavy. Is if the guy carry, it's like this, portable. And also the simple simulator is embedded in upper side. Simple simulator. And it can be operated with a physical controller. You can see, can you see physical controllers in here? Around here. Steering wheels, brakes, and ignition. Can you hear me? After that, I can show the videos. And we equipped some attack surfaces, which is very typical. Since it is very easy to simulate a CAM message injection, security violation is easy. You can modify the program of these ECUs in C language, and the attack surfaces are OBD2, equipping area, physical equipping, and junction box. No need to shoot a picture. You can download this material from GitHub. Please concentrate my presentation. Listen to me. So next, information flow in pasta is maybe it's detailed. The dash case controller is control peak is simulators are integrated, and also the physically you operate the controller and send a message to ECUs, each ECUs, and receive the message of controls. ECU calculate, and they send CAM messages to share the information via CAM messages, and they ECU construct feedback according to received CAM messages. So if for example, if you steering wheel turn right, then the control message is going to ECUs and share the degree, and then the ECU send CAM messages, share the information, and then the body or tires going to right. So yes. So inside of ECU is like this. Of course, it's open, and design is also open. Is in GitHub. You can download and check it. And also, CAN ID table is opened. Most of all vehicle companies make it secret, the CAN ID table, but in pasta, we can make it open because we designed itself ourselves for pasta. So the CAN IDs of this one is is different from real ones. But you can create your own table. This is very important. The news, again, a dark reading, say that Toyota opened their CAN ID tables. It's wrong. Pasta's CAN ID table will be opened, and we opened. It's completely different. It's not real thing. It's not upright in real vehicles. And we hope that the CAN ID tables and the rules is, I guess, it's not perfect because it's developed by engineers who do not know security. So hackers who know the security design the CAN ID tables. It's, I believe that by design, security by design. So I hope that this the example of CAN ID table will be spread, and you can design CAN ID tables. It's completely different from Toyota open CAN ID tables. Please understand that my real opinion. That is, this is very, very different from CTFs, which is searching for what the CAN ID is, means the problem. The CTFs is just only analyzing what the CAN ID means. This is not, it's not creative. Creative is you can design CAN ID table. That's why I doubt that CTF is really good way to run or not. I'm sorry for CTF, guys. CTF itself is very fun and also very useful, I believe. So, but I would like to say different viewpoint. So you can download a GitHub specification from the GitHub. I uploaded a few days ago. Please visit Pasta.ot and click the doc, and you can download the CAN ID list from here. So back to inside of ECUs. Can I have a time? Do I have a time? Okay. Yeah, inside of ECUs, there are RS-232C port and JTAG port. Via this port, you can upload your binaries. Of course, you get the binary from here. Based on the microcontroller RX, which is by Renesas, we have designed and developed the ECU from scratch. If you prepare for develop environment in Renesas microcontroller, you can apply your own program in C language. It's about very adaptable. So I'd like to show the adaptability of pasta. It's a whole image of now we prepare for the pasta. The center is the attached case of pasta. So pasta can connect the physical inputs and also connect the scale model of vehicles and also connect the vehicle simulator. So demonstration of adaptability. First, I would like to show the connection of pasta and the scale model of vehicle. Here is the connection of pasta and miniature vehicle. First, power on. And then ignition like real vehicle. If you brake up, the braking is 100%. So shift position, you can change the positions. Actually, the miniature camera has a miniature vehicle has a miniature camera, so it works in a shift position. Some lights it brings hazard lights, and you can see the steering is going to the right and also going to left according to the controls of pasta. The control message is pasta send miniature vehicle via Bluetooth. The simulator situation status is sent to a miniature vehicle and receive the miniature vehicle. Windshield wipers also moves. The speeding up and speeding slow, speeded that down. It's very tiny, but it works very real because it's made in Japan. Of course, washer doesn't work because if the washer works, the miniature vehicle will be broken. So it's a bit wrong, so skip. When accelerator is 100%, it becomes the speed is very fast. But tires is not 199 kilometers per hour because there is no feedback from vehicles. So it's very, it's not so real. So we solved that to make it more real, integration of driving simulator with pasta. This is the okay. Connection of a real vehicle is sorry. The slide is omitted, but physical input and pasta and software vehicle simulator, not scale model vehicle. So here is a driving simulator connection. Now the behavior is very smooth. The physical controller send the controller message to pasta, and send the CAN message to simulators, and simulators send back feedback to pasta. So it's completely different from a controller is directly connected to a simulator. This simulator is controlled via CAN. So speeding up is very natural. Natural. So it becomes natural. We can show that, of course, the incident, replicate the incident. Before the incident demonstration, we have to say that, explain the demonstration, the caution. Next demonstration is send a message from OBD2 port, malicious messages from OBD2 port, and also there is no security systems in pasta. There is no filters in ECUs, and also no safety functions in ECUs. So it's very easy to manipulate and control the vehicles. So it's different from real vehicle. Real vehicles hacking is much more difficult. And also, this is not a Toyota vehicle, I believe. So demonstration of incident. Attacking a steering wheel. Right side of attacker's is attacker's PC. This video including a sound. So attacker's PC. Now it's driver's hands off. Attacker's PC send a malicious message, set steering, going to please see right here the driver's hands off, but the steering tire is going to right again. Please check it. Driver's hands off. This is incident replication. Okay, so at last we present some use cases of PASTA. Of course, it's very easy to for educational use. Real canvas and typical attack surfaces will help beginners to learn vehicle security. The girl is reading a car hacker's handbook, and also the right guy is in the right side is programming and sending a message to a PASTA. It's very easy way to education of vehicle cybersecurity. And also it's very comfortable. They can hack inside of room. And more CTF. A lot of guys can hack the PASTA. It can be it's one example of use case of PASTA. And also research and development. Many kinds of security techniques can be applied to PASTA, and it works as a common platform security evaluation. And security techniques, which is developed by vendors or researchers, can be evaluated on PASTA. So if you, the researchers upload their security systems in website or somewhere and apply it to a common platform, this PASTA, and anyone can evaluate the security. The security systems techniques is secure or not. You can find it. And finally, roadmap. For more advanced and realistic architecture, there are more protocols in vehicles, such as RIN, CAN-FD, Ethernet, and so on. So we have to support, PASTA have to support these protocols. And also, PASTA can only support CAN messages, canvases, CAN protocols. So there is no such navigation systems or multimedia unit. So support wireless interfaces needed, like a Wi-Fi, Bluetooth, and cellulars. And now PASTA has only 3 domains. Currently, the current vehicles have much more complicated and much more domains. So we plan to make it more realize more complicated architecture. And support other systems is something like OSs, and this is an additional. So open the source code on GitHub. We uploaded our materials and the features to GitHub a few days ago. In time this Black Hat Asia, but the source code is not yet uploaded. So we will upload, preparing for that. So takeaway, in spite of vehicle security importance, any common platform for research has not been developed. PASTA can be a platform. So PASTA is open and safe, adaptable, and portable. It's very light and small, apparently portable. The design of PASTA is open, and anyone can program, reprogram, and change the ECU's behavior. And PASTA is harmless for students, researchers, hackers. So because actuators are simulated in software. So we hope that PASTA will be a common platform for educational tools, automotive cybersecurity research and developments. For more information, please contact Twitter, GitHub, and mail. This email will be expired by the end of April. So, because of our company will disappear again. So we will upload a new contact mail address in GitHub and Twitter. So if you interested in PASTA, please contact from somewhere. So before the Q&A, frequently asked questions, FAQ. We had a lot of mails, tons of thousand mails from all over the world after the presentation of Black Hat Euro. Thank you. So our most frequent question is, how much is PASTA? Now we discuss some guys who will in Toyota to sell this product. In this current situation, considering current situation, it becomes the price will be similar to actual car. And next frequent question is, when can I buy PASTA? Sorry, I don't know. We are planning to start selling in Japan first, and it plans to sell it to other countries afterwards. But we now plan to sell in Japan this summer. It may be. And why the specification of PASTA is not open yet? We uploaded the specification PASTA a few days ago. So please do not any this question to us by email. Sorry for late. Additionally, source code and detailed information will be uploaded soon. So, questions? Thank you. My company will go to very near to Otemachi, very near to Tokyo Station. So please come to Tokyo Station and by walk to come to Otemachi building, 6th floor. There is our company.
Something like an event or live demo.
Not planned, not yet. Anything else? Okay, thank you.